Good morning, everyone. How are you all? Hope you are all fine. Okay, right. In the previous classes, okay, we have completed first and second units and all the derivations. Okay, every day, each and every day, you go through the derivations. Okay, children. Okay, study well. Don't waste your time. Okay, make your mind free. Okay, don't be tensed. Okay, study in a jolly mood. Okay, give more importance to studies. Okay, you love to study, okay, then only it will be an easier one. Okay, if you hesitate it will become very tougher for you. Okay, so enjoy the studying. Okay, very interesting subjects are there in 12th standard. Okay, right. Are you doing the homeworks and classworks properly? Okay, I'm believing that you are doing well. Right. Okay, let's start the lesson. Okay, right. First of all, today in this unit we are going to see about magnetism and the magnetic effects of electric current. Okay, have you seen have you seen magnetic's property? Okay, have you go through the magnets? Okay, have you experienced the magnetic field property? Yes, each and every students have seen the magnets. Okay, right. So we all know about this magnet. Okay, now we are going to see these magnets are used in which field. Okay, how the earth is having a magnetic field. Like that, many questions are in our mind. Okay, so the physics deals with nature. Okay, all the things in nature is deals with physics. Okay, let's see one by one. First of all, what is magnetism? Okay, what is magnetism? Right, so the force of attraction or repulsion of a magnetic material due to the arrangement of its atoms, particularly its electrons. Okay, what is magnetism? The force of attraction or repulsion of a magnetic material due to the arrangement of its atoms, particularly the electrons. Okay, so the earliest magnets were found naturally in iodostone. Okay, that is used by ancient people as compasses. Okay, see the picture, that is a compass. Okay, have you seen in laboratories the magnetic compass? Okay, if you haven't seen, in this year we can see. Okay, right. That magnets produce magnetic forces. Magnets produce magnetic forces and have a magnetic field lines that shows the location of the magnetic field. Okay, see the picture, there is a magnet. Okay, that is north pole and south pole. Okay, the lines around, okay, the lines around the magnet is called the magnetic lines. Okay, you understood? Right. Okay, what is magnets? Yeah, no doubt. Their behavior will attract everyone. Okay, each and everyone like the magnets. Okay, so the world enjoys the benefits. Okay, to lead a modern luxurious life. Okay, so the study of magnets that fascinated the scientists around the globe for many centuries. Okay, and even now the door for research on magnets is still open. Okay, up to now also the research on magnet is going on. Okay, so I will tell you one thing. Many birds and animals have magnetic sense. Okay, many birds and animals have magnetic sense. Okay, in their eyes using Earth's magnetic field of navigation. Using the Earth's magnetic field for navigation. Okay, so magnetic sensing in eyes for zebra. Okay, the bird uses Earth's magnetic field for navigation. Okay, the birds are using the Earth's magnetic field. Earth is also having a magnetic field. Okay, let me tell one by one. Okay, right. This magnetism exists everywhere from tiny particles like electrons to the entire universe. Okay, magnetism, okay, that occurs in tiny particles like electrons to the entire universe. Okay, historically the word magnetism was derived from the iron ore magnetite. Okay, derived from the iron ore magnetite. Okay, in olden days magnets were used as a magnetic compass. Okay, see the picture, that magnetic compass. Okay, that is used for navigation, magnetic therapy for treatment, and also used in magic shows. So in modern days, many things, okay, many things we use in our daily life. Okay, many things we use in our daily life that contains magnets. Okay, motors, cycle dynamo, loudspeakers, magnetic tapes, okay, used in audio and video, used in recording, okay, mobile phones, headphones, the CD, in pen drive, in hard disk of a laptop, refrigerator, door, generator, okay, these are the few examples, okay. Now in modern days, many things we use in our daily life that contains the magnets, okay. Motors, cycle dynamo, loudspeakers, magnetic tapes that is used in audio and video recording, mobile phones, headphones, that CD pen drive, hard disk of a laptop, okay, refrigerator door, okay, as you open and close, there is a magnet, okay, so and generator also. These are the few examples, okay. Right. Earlier, both electricity and magnetism were thought to be two independent branches of physics. Okay. In past, okay, in classical physics, okay, they thought that magnetism and electricity is the branches in physics. Okay. That Oersted, okay, he's a scientist. He observed that deflection of magnetic compass, okay, deflection of magnetic compass needle kept near a current carrying wire. Okay. If this compass magnet kept near a current carrying wire, this unified, okay, this unified the two different branches, that is electricity and magnetism, as a single subject, okay, that electromagnetism, that is called the electromagnetism. So electricity and magnetism, it combines and it becomes a great branch in physics, that is electromagnetism. Sorry, so in this unit the basics of magnets and their properties are given, okay. Later, how a current carrying conductor, okay, behaves like a magnet is present, okay. So let us see one by one. So see here, these are the applications of magnetism, okay. In MRI scan, okay, in MRI scan, okay, that is a magnetic resonance image, okay, in cancer patients, okay, this MRI scan is very important to detect the cancer cells, okay. So it is used in magnetic fields, sorry, medical fields also, okay. So this, it is a very important property, that magnetism, okay, it is used in motorcycles, motors and cycle dynamos, loudspeakers, magnetic tapes, okay, and mobile phones, headphones, CD, pen drive, hard disk of a laptop, refrigerator door, generator, okay, these are the few examples, okay. So it is used in MRI scan, laptops, okay, headphones, okay, these are the great examples for magnetism. Now, we are going to see about the Earth's magnetic field, okay. Right, from the activities that is performed in your lower classes, okay, you might have seen the needle compass, okay, that magnetic compass, there is a needle, it will deflect if there is a magnetic field, okay, or freely suspended magnet that comes to rest in a position which is approximately along the geographical north-south direction of the Earth, okay. Right, the north pole of magnetic compass needle is attracted towards the magnetic south pole of the Earth, which is near the geographic north pole. Okay, similarly, the south pole of a magnetic compass needle is attracted towards the magnetic north pole of the Earth, which is near the geographic south pole. See the picture. There is a magnetic compass needle that is attracted towards the south pole of the Earth, which is near the, okay, there is a magnetic north magnetic pole, geographic north pole, geographic south pole, and south magnetic pole, right? Now, see the picture. The north pole of the magnetic needle attracted towards the south magnetic pole, right, which is near to the geographic north pole. Okay, similarly, south pole of the magnetic needle attracted towards the north pole of the Earth, which is near the geographic south pole. Right. So the branch of physics, okay, which deals with the Earth's magnetic field, that is called geomagnetism or terrestrial magnetism. Okay, the branch of physics which deals with the Earth's magnetic field, that is called geomagnetism or terrestrial magnetism. Okay, so there are three quantities that is required to specify the magnetic field of the Earth on its surface, so which are often called as the elements of the Earth's magnetic field. They are the magnetic declination, that is capital D, and magnetic dip inclination, that is I, the horizontal component of the Earth's magnetic field, that is denoted by BH. Okay, right? So this day and night, okay, the day and night, okay, that occurs, okay, day and night occurs because Earth spins about an axis, okay, Earth spins about an axis that is called geographic axis, okay. So a vertical plane that is passing through the geographic axis is called the geographic meridian. Okay, and a great circle that is perpendicular to the Earth's geographic axis is called the geographic equator. Right? The straight line which connects magnetic poles of Earth is known as magnetic axis. Okay, a vertical plane that is passing through the magnetic axis is called the magnetic meridian, and a great circle that is perpendicular to the Earth's magnetic axis, that is called the magnetic equator. Right? Now, let's see what is the declination. Okay, so what is inclination, like that. So when a magnetic needle is freely suspended, the alignment of the magnet that does not exactly lie along the geographic meridian. So the angle, okay, the angle between the magnetic meridian, okay, see, center the sun and Sutti, that is the Earth, okay. See the November, December, June, okay, the months how comes and the day and night how occurs, okay. So the angle between the magnetic meridian, see the angle between the magnetic meridian at a point and a geographical meridian. Angle between magnetic meridian and geographic meridian is called the declination. Okay, so at higher latitudes, the declination is greater. So whereas near the equator, the declination is very smaller. So in India, the declination angle is very small, and for Chennai, magnetic declination angle is, okay, 1 degree 16 dash. Okay, right. So the angle subtended by the Earth's total magnetic field with the horizontal direction in the magnetic meridian is called the dip or magnetic inclination. So for Chennai, the inclination angle is 14 degree 28 dash, right? The component of Earth's magnetic field along the horizontal direction in the magnetic meridian is called the horizontal component of Earth's magnetic field. Let B be the net Earth's magnetic field at any point on the surface of the Earth. So BE can be resolved into two perpendicular components, that is horizontal component and vertical component. Okay, horizontal component and vertical components. Right, at a magnetic equator, what happens? At magnetic poles, what happens? Okay, let us see. Okay, first of all, at magnetic equator, okay, so the Earth magnetic field is parallel to the surface of the Earth. Okay, magnetic field of the Earth is perpendicular to the surface of the Earth. So, which implies that the needle of a magnetic compass that rests horizontally at an angle of dip, that is I equal to 0 degree. So, this implies that the horizontal component is maximum and the vertical component is 0 at the equator. Next, at the magnetic poles, okay, the Earth's magnetic field is perpendicular to the surface of the Earth, which implies that the needle of magnet compass that rests vertically at an angle of, that is, 90 degree, okay. Right, this implies that the vertical component at a maximum poles and the horizontal component is 0. Horizontal component is 0, okay. Now, what are the properties of magnets? Okay, this magnet attract the objects of iron, cobalt and nickel. Magnet attract the objects of iron, cobalt and nickel. Okay, the force of attraction of a magnet is greater at its poles than in the middle. Okay, force of attraction of the magnet? Force of attraction of magnet is greater at its pole than its middle. Understood, right? So, like poles of two magnets repels each other. Like poles of two magnets repels each other. Opposite poles of two magnets attracts each other. Okay. So, if a bar magnet is suspended by a thread and if it is free to rotate, its south pole will move towards the north pole of the earth and vice versa. Okay. If a bar magnet is suspended by a thread and if it is free to rotate, its south pole will move towards the north pole of the earth and vice versa. Do you understand? Right. Okay. These are the basic properties of magnets. Okay. Let us see some of the basic terminologies and properties that is used in describing the bar magnets. Okay. Basic properties of bar magnet. First of all, that is the magnetic dipole moment. Magnetic dipole moment. Okay. So consider a bar magnet. Okay. Consider a bar magnet. Okay. Having south and north pole. Okay. So Q be the pole strength of the magnet and L be the distance between the geometric center of the magnet. Okay. And what happens? The magnetic dipole moment is defined as the product of its pole strength and magnetic length. Okay. The magnetic dipole moment is defined as the product of its pole strength and magnetic length. Okay, it is a vector quantity and it is denoted by P. Right? This is the magnetic dipole moment. Okay, a current loop that produces the magnetic dipole moment. Okay, it is defined by mu m is equal to IAUM. Okay, it shows the direction that flows right through. Next, the magnetic moment experiences a torque in magnetic field to align it with the B. Okay, right? Magnetic moment produces a magnetic field around it. Okay, the produced B is proportional to mu m and inversely proportional to the distance. So the magnitude of magnetic moment is P. Okay, P equal to 2QL. Okay, so the SI unit of magnetic moment is AM square. So the direction of magnetic moment is from south pole to north pole. South pole to north pole. Now, magnetic field. So, magnetic field is the region or space around every magnet within which its influence will be felt by keeping another magnet in that region. Okay, magnetic field is a region or it is a space around every magnet. Okay, see the magnet. So, the around space. Okay, kept keeping another magnet. Okay, right. The magnetic field at a point. Magnetic field is defined by the point B, okay, AB. Okay, so the magnetic field at a point is defined as a force that is experienced by the bar magnet of unit pole strength. Okay, so its unit is N, A inverse and M inverse. Okay, so magnetic field B is equal to 1 by QM F, that is force. Okay, this is the magnetic field. So the area around a magnet where the magnetic force could affect other objects. Okay, this is the magnetic field. See here, this is the magnetic field line. This is the magnetic field lines. Okay, so magnetic field lines are continuous closed curves. Okay, magnetic field lines are continuous closed curves. Okay, so the direction of magnetic field lines is from north pole to south pole or outside the magnet, and from south pole to north pole, that is inside the magnet. See the picture, north to south, that is inside the magnet, south to north, that is outside the magnet. So the direction of magnetic field at any point on the curve, direction of magnetic field at any point on the curve is known by drawing tangent to magnetic field lines at that point. Okay, so magnetic field lines never intersect each other. Magnetic field lines never intersect each other. Otherwise, the magnetic compass needle would point towards two different directions, which is not possible. Okay, so the degree of closeness of the field lines determines the relative strength of the magnetic field. Okay, so the magnetic field is strong where magnetic field lines crowd and weak where magnetic field lines were separated. Magnetic field is strong when the magnetic field lines are crowd and when weak where the magnetic field lines get separated. This is the magnetic field lines. Okay, right. So what are the properties of magnet? A freely suspended bar magnet will always point along the north-south direction. Okay, see magnetic field lines. Okay, we can describe the magnetic field lines by imagining a tiny compass placed at the nearby points. Okay, we are having a magnet north and south pole and there is a compass. Okay, it will denote the deflection. Okay, the direction of magnetic field at B, at the point B, magnetic field B at any point. Okay, the direction of magnetic field at any point is the same as the direction indicated by this compass. So the field B is strong where the lines are dense and weak where the lines are sparse. Okay, if they are dense, the field is strong. If they are separated, the lines will become weak. That's all. Okay, right. Let me tell the properties of magnet. Okay, magnet properties of bar magnet. Okay, that is a freely suspended bar magnet. It will always point along the north to south direction. Okay, magnet attracts or repels another magnet. Okay, so when a magnet is broken into pieces, each piece behaves like a magnet. Each piece behaves like a magnet. Do you understood? When a magnet that is broken into pieces, each piece behaves like a magnet with poles at the ends. Okay, right? The two poles of a magnet have a pole strength that is equal to one another. Two poles of a magnet have a pole strength that is equal to one another. Next, the length of the bar magnet is called the geometric length, and the length between the magnetic poles in the bar magnet is called the magnetic length. So, magnetic length is always slightly smaller than the geometrical length. Next, the ratio of magnetic length and geometric length is 5/6. The ratio of magnetic length and the geometric length is 5/6. Okay. And what are the types of magnets? Okay. So magnets are classified into natural magnets, artificial magnets. Magnets are classified into natural magnets and artificial magnets. For example, iron, cobalt, nickel, etc. Okay, that are natural magnets. The strength of natural magnets are very weak and the shape of the magnets are irregular. You understood? Strengths of natural magnets are very weak and the shape of the magnets are irregular. Natural magnets. Okay. So artificial magnets are made in order to have a desired shape and strength. Artificial magnets are made to have a desired shape and a strength. If the magnet is in the form of a rectangular shape or a cylindrical shape, then it is known as a bar magnet. Then it is known as bar magnet. Okay. That's all about today's class. Okay. Next class we will see about the magnetic flux and all the uniform magnetic field, etc. Right? Write down the today's homework. Write 10 one words from page number 126 to page number 133. Okay. Write any 10 one words. Okay. Right. And write the properties of magnet, page number 130. Okay, there is a 5 point. Okay, properties of magnet. Go through it. Okay, study well and write the properties of magnet. Also study the basic properties of magnet: magnetic dipole moment, magnetic field. Okay, types of magnet, magnetic field lines. Okay, go through it and study well. And your assignment is properties of magnet. Assignment is properties of magnet. Okay, children, that's all about today's class. Okay, study well. Don't waste a single time. Okay, have a nice day. Thank you.